Hello guys, Jay Sideris here. The other day I made some channel art for my other YouTube channel. Just a heads up, this project did require a little bit of 3D modeling and programming. Take a look at this shit right here. Okay people, I can already see the looks on your faces and I know exactly what you're thinking and there's no need to be coy about it. Just look at these elaborate skull decals, or the way that light reflects off of these surfaces. Yes, people, you are looking at a modern masterpiece, the birthchild of engineering and pragmatic art, form and function. It's so great that Donald Trump has already announced that he's going to be applying a 25% tariff to it. And rightfully so, you're probably wondering how you can build the exact same thing for your channel. Well, don't worry, boys and girls, I'm going to tell you how this was built right here, right now. Step one is that you're going to have to get some 3D modeling software and get some 3D letters going. Hold your horses there, folks. I'm not talking about the 3D text effects that your word processor from 1993 gives you. You actually have to have a 3D mesh. This is kind of the hard part, and to be perfectly honest, I really suck at it. But there are a few free tools out there. They're incredibly difficult to use for someone who has never done it before. But if you're interested in learning 3D modeling, it might be something interesting to pick up. Probably one of the most popular tools out there is Blender. I think that there's a free version of Autodesk available. Google SketchUp. I'm not sure if SketchUp will work for what I did. But I didn't use any of these softwares actually because I don't know how to use any of them. Actually, I've used a little bit of SketchUp, but I think they've changed their model so that you can't get the free version anymore. I'm not entirely sure about that. But I am familiar with the file format that 3D meshes are saved as, at least one of the file formats. I guess there are different types. I'm familiar with the OBJ file format, and I've previously used it to build some 3D rendering software for a project that I've been working on. This particular software is more for building houses and mazes and buildings, kind of like The Sims build mode. And using this platform, I just built each letter one at a time as a bunch of tiles stuck together in the shape of a letter. And I found a font which would specifically be blocky so that I wouldn't have to worry about things like curvature and roundness. Now, one of the things this software does is that if there's a bunch of tiles that are next to each other, instead of drawing them all as individual tiles, it will draw them all as one big massive tile. And that saves up a lot of memory, and since the software is primarily intended for game development, being conservative with memory and processor resources was a priority. But because I wanted to have that exploding effect, I decided to turn off that optimization in the code, so this is what the mesh looked like when the tiles were not being merged together. Now this software is still in the early alpha stage, so it's not online yet and other people won't have access to it. But in the meantime, there are many other 3D modeling softwares that you can use. Once I had generated all of the letters, I imported them into Unity, which is a game engine for those of you who are unfamiliar, and I positioned them in the scene appropriately. Then I positioned the main camera directly above the letters, and I textured the letters. Now to texture this, I just found a random height map on the internet, on some website, and I decided to import it into Unity. And it's important that when you're looking for height maps for game objects, that the width and the height have to be equal and they have to be a power of 2. So I picked a height map that was 124 by 124, which is 2 to the power of 10. And I just used the advanced search tools in Google Images to accomplish that. So I got this height map, and then from the height map, you also have to generate another thing called a normal map. This stuff is a bit too technical for me to talk about on this channel, but if you're interested in learning the purpose of height maps and normal maps, there are some good resources online that will explain what everything does, but essentially it's a way of telling the game engine how light should reflect off the object. So you generate a normal map from a height map, and there's an online tool to do that, and I'll post a link to this tool in the video description. And so now that you have your height map and your normal map imported into Unity, you can just apply them to a new material and apply the material to each object in your scene. Moving on to the rotations, they kind of gave me a bit of trouble because my initial plan was to make it so that the rotations were all perfectly aligned with the camera, and then they would rotate into something that was more haphazard, and then I would record that and then just play it backwards. Because it's a lot easier to go from something that's orderly into something that's haphazard, and a lot more difficult to go from something that's all randomized and haphazard into something that's more orderly. So that was the goal here, but then after recording, I found out that the recording software that I'm using to edit the videos, which is Camtasia, doesn't actually have the ability to reverse a video clip. And that really threw a wrench in my plans, and so I had to come up with a better solution. And so what I did was, my solution was that as I rotate the object, there's like a rotation speed multiplier that I'm using that determines how fast the objects will spin. And then what I do is I just record that in a giant buffer frame by frame so that I know, I kind of have like a history of the rotation speed of each object. And then when it comes time to play backwards, so I play that forwards and it randomizes the text. And then I just go backwards through that buffer and basically reverse all of the rotations, and then it'll put the rotations in an orderly form. Well, that was the plan, but after I implemented it, I realized that I had made a mistake somewhere. For some reason, the text never really fully aligns just right with the camera. It's always off by a little bit. It's almost as though one of the rotation update steps is being skipped during the reverse rotation phase. But I actually liked it. I mean, it looks kind of stylistic, so I decided to roll with it. I didn't bother fixing this problem. Onto the exploding phase, this one was a little bit more tricky. I had to find a script online that would loop through my mesh and explode it. And all that does is it loops through all of the triangles in the mesh, because the mesh is made out of a bunch of triangles, and it will erase the main mesh and then add a whole bunch of objects that represent the individual triangles within the original mesh. And then it just adds like a random explosion force to them so that they kind of go in all directions. But when I ran it, I found that it kept crashing, and I guess there were too many triangles or too many objects on the screen at once. Now, when a triangle is part of a larger mesh, the entire mesh is processed as one giant object. And in fact, with the original letters, Unity's physics engine was turned off, so I'm not even considering it as a rigid body. But as soon as the mesh turns into a bunch of triangles, every single triangle needs to have physics applied to it. And I'm not really sure how Unity's physics engine works internally, but I know that if you have a lot of objects that are in close proximity to each other, it raises the possibility that there's a lot of different collisions going on, and so the physics engine typically would need to exert a lot of processing power to determine whether objects that are close to each other might be touching. And if you have a lot of objects that are touching all at once, it can create very interesting structures like trusses and things like that. You can think of that, or stacks that are computationally difficult to process. So again, I'm not really sure how Unity deals with stuff like that, but in my case, this was just crashing the simulation right away. And so what I had to do was I just tweaked that code I found off the internet that explodes the meshes, and I made it so that instead of drawing whatever, tens of thousands of triangles or whatever it was doing, I made it so that it would only draw 1 in every 33 triangles. Oh, and here's something interesting. It had to be an odd number that I was skipping over each time. So it had to be like 1 in 33, 1 in 39, 1 in 27. If I had picked 1 in 34 or 1 in 30 or 1 in 32, then all of the triangles would have ended up pointing the same direction when they get generated. And that's because the mesh is composed of a bunch of squares, and each square is composed of 2 triangles. And you don't always want to pick the bottom triangle, you want to pick alternating triangles. This sounds complicated, but it's not like I thought of this in advance. I basically built the script, and then I found that when the letters were exploding, all the triangles were pointing in the same direction. I knew what the problem was right away, and then I just changed it from using 1 in every 20 triangles to 1 in every 21, and the problem was fixed. And then later I settled on 1 in every 33. And of course, because I'm using fewer triangles, I decided to make the triangles bigger. So I only made them 10 times bigger, and I found that that worked well enough. And that's it. I mean, the results speak for themselves, and it wasn't all that much work to put together. Anyway, guys, thanks for watching. Subscribe for more. Jay Sideris.